Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU in partnership with 40 UN sister organizations and co-convened with Switzerland.
Hello everyone, and thank you for joining our session today. Welcome to AI for Good and our webinar on Machine Learning in 5G Challenge. My name is Nishio from ITU, the International Telecommunication Union, the United Nations Specialized Agency for Information and Communication Technologies. The Machine Learning in 5G Challenge, now in its third year, aims to create a community to solve network-related problems using machine learning. The challenge this year features a dozen problem statements all over the world. Today, we are very excited to introduce a problem statement from ITU's AI for Good team titled Slidin videos, slide transition detection and title extraction in lecture videos. We are counting on you, the participants, to help create an engaging discussion. If you have any questions, please type them in the video wall and we will take them during the Q&A session right after the talk. Without further ado, I would like to introduce today's first speaker, Bastiaan Quast. Bastiaan is a Dutch-Swiss economist and data scientist with ITU in the AI for Good team. He is the main author of the open source RNN deep learning framework in the R programming language and the datasets load package as well as R packages on global value chain decomposition and WIOD and on regression discontinuity design. Our second speaker will be Kirill Ekshembeev, a consultant at ITU who works as a machine learning practitioner committed to solving the most intricate problems and discovering the unknown. Over to you, Bastiaan.
Thank you very much, Miya, and let me just pull up my slides and we can get started. So thank you to all the participants from joining. I hope you can all see the slides on the screen now. And so, as Miya already mentioned, this is the Slidin Videos Challenge as part of the MO5G Challenge organized by ITU. And this particular challenge is something that came out of the AI for Good team at ITU as well, where we have published over 100 webinars over the past 2 years or 2+ years. And we now want to present this as a data set to be analyzed in terms of creating video chapters of these lectures. So let's get into it. What are, this is the short outline of the talk for today. We start with the introduction of what video chapters are, what the challenge looks like. I'll be covering these two aspects, and then I will hand off to my colleague Kirill, who will talk about the training data set that we'll be publishing as part of this challenge. And we will conclude with a discussion on how you can get started in as participant in this challenge, creating and submitting your solutions for this competition. And then we'll end with a Q&A with Vishnu. So video chapters are something that you may know from other online video platforms such as Vimeo, Chincopa, etc. And they segment an online video into different chapters, and the chapters have a beginning point, an end point, and a title. And the idea is that this has various benefits, including helping viewers create a sort of mind map. In particular, when you give a video lecture, this is something that will really help convey the structure of of the message that you're trying to get across. And additionally, it also helps content creators in the sense that they make sure that they structure their presentations very well before they are put online. So as I mentioned, beyond YouTube, there are other services like Vimeo, Chincopa, and etc. And you see roughly here a screenshot of what it looks like when there are chapters in a video. And so let's have a look at exactly what that means. When we zoom in on the same slide, we see here at the bottom 3 boxes that I highlighted in green. The first are the black tick marks in the red progress bar. And so, well, the red is the completed section of the video. And when it's uncompleted, it's gray and you still see the black tick marks. So these are the chapter delineations where chapters end and new chapters start. Then right next to the sort of total runtime of the video, which you see at the bottom, it says test and improvements of the robustness of neural networks. We'll be zoomed in on this a bit. That's the title of the chapter that we're currently playing. So you see the red dot in the progress bar, which shows where we are. And in that title, between the preceding black tick mark in the red and the subsequent black tick mark in the gray, this title, this chapter has the title here. And then finally, when we hover into future or past sections of the progress bar with our mouse, we get a preview box of the video feed at that point in time, as well as the timestamp of the preview. And now when we have chapters, we also see the title of the chapter that we're looking at there. And so here it says, for instance, at the timestamp 43 seconds past 40 minutes, that is the start of Q&A. Now, what does this do? Well, first of all, it helps everyone with faster maneuvering through videos. But in addition to this, there are also benefits, in particular for persons with disabilities, such as visual or hearing impairments, which with this metadata can be assisted into getting a better understanding more easily of what the video is structured like. And then we've already discussed the user interface elements, the 3 that you see at the bottom. So moving on, what else is there? Well, it also helps with the metadata also helps with searching in videos. So here you see a screenshot of a search query on a major internet search engine. And in addition to the video, which is the first result here, we also see how the video is broken down, and we see different sections with the timestamps there. So we see representation theory at 2 minutes and 29 seconds. We see volume conjecture at 16 minutes and 1 second, etc. And so in addition to the video being broken down and showing much more content of the video, it's also possible to, when you search on such a search engine, that you are directed to a specific section within a video, the way that you might be directed to a specific page on a website. Okay, so currently major platforms such as YouTube sometimes generate these chapters automatically for videos. Yet there are some limitations to that, to this auto-generated chapter system. Firstly, it's proprietary, so it's not something that everybody can just use. Secondly, it is not open source or open code, as you will. It is not auditable in any way, so we do not know how, why these chapters are created. There's also no recourse in the sense that we cannot ask the system to adjust the titles. And finally, it's not always available. So it's algorithmically determined whether or not the video that you upload will have the option of these chapters or not. And so we can't always ensure that these chapters are automatically generated by the system that is there. However, we can, by editing the description, as you see here in the screenshot, add the chapters manually. Now, creating them manually is a lot of work, and so that's what this challenge is about. What we want to do is create AI models that automatically see when there are slide transitions and what the new slide title is, which will be the proxy for the chapter title. And then with that information that we generate with the models here, we can then edit the description in the way that you see here in the green box. And as you see, the timestamps are automatically picked up, and it shows also in the progress bar the tick marks of the chapters, as well as the chapter title in the preview there, and the chapter title of the current chapter, the 3 elements that we previously discussed. It has a specific structure, so 1 line per timestamp. And then it does show these UI elements. Okay, something about the challenge now. So the challenge has two components. Firstly, it's detecting the transition. So when does a slide change in a lecture? And typically this is quite straightforward. There are slide numbers, the title changes. You might also have audio cues, such as when screen sharing is done by a certain, not by the speaker, in which case the speaker will say something like presenter hint like next slide. And then what can be less titles often is the second component of the titles of the slides will be the proxy for the chapter title, and these are typically obvious, but there are more complex scenarios. So in certain cases we see no title. In certain cases we might see two columns or something like that, or multiple columns, each of which has a sort of title, and so it's not exactly clear what is the title, the single title. Then in some cases the slides are malformatted so that we see a partially covered title, or the title might run off screen in case it is too long, and various other cases, as well as things happening like presenters going out of their presentation and then into a, let's say, a video demonstration, a screen share demonstration, which is different. So here's an example of a title which is very obvious. It's example notes and invariants. The source here is the DeepMind talk at AI for Good on 27 January of this year. And this is quite straightforward, and we expect people to be able to, participants to be able to do this quite straightforwardly. However, there are also some more complicated scenarios. So here we see the large text, which is the title nature of the paper here. But nature, of course, is not the title of this slide. And so the phrase AI guided intuition would be a better fitting term here, which is the title of the article that they're talking about, rather than the title of the journal as a whole. This is more complex, and we expect that models that participate in this challenge can also distinguish when these types of scenarios occur. Okay, so in terms of criteria for evaluation, for every video in the test dataset, we expect the model that is submitted by participants to create a single file. And the file will contain boundaries of the various chapters predicted, which are collectively exhausting in the sense that so every second or every frame in every test file is accounted for in a specific chapter, and then there's a title associated with that, or in outlier cases, it says that there is no title associated, such as a scenario when a video demonstration is being performed in the middle of the presentation. Here, a short snippet of what a prediction file will look like. So it has a header, when the starting frame, the end frame, if it is indeed a slide being shown during that frame, in which case the binary value is 1, or if it is not a slide, such as a video demonstration or something else, then the binary value is 0, and then the title associated with it. So here you see these elements, and we have also published demonstration material on the challenge website. And then in terms of the prediction process, so things happen. As you know, many types of presentation formats use a sort of fade-in effects, and various elements might appear on the same slide. So the slide might be looking different through various stages of this chapter. That's something to also take into account. Then here's another mention of the is slide binary value, which signals whether the time frame referred to with the starting frame and the end frame is indeed a slide being presented or something else being shown on the screen. Then non-slide content can be identified through proxies such as tracking the pixel refresh ratio. And here, then finally, you see kind of illustration of what I just mentioned in the previous slide, how all the frames, how the delineation of the chapters is a collectively exhausting set that ends with where each frame of a new chapter is the frame subsequent to the ending frame of the previous chapter. And you can see that here. With that, then it's now time for me to hand it over to my colleague Kirill, who will talk more about the training set, and then finally we will get into the getting started and the Q&A. Kirill, so with that, over to you.
Thank you, Bastiaan. Should we go to the next slide? Perhaps. Yeah. So we basically we processed 100 webinars, and we were basically extracting every screen share which was done by the presenters. And the current data set which we have, it has 140 screen shares, or AKA video presentations. And the total duration of these video presentations, that would be 40 hours. So we're giving you 2,500 slide transitions, which is not necessarily a unique slide, because sometimes presenters might they might go back to the previous slide, or they might even scroll through the whole presentation. So we want you to account for every slide which was shown in the video, even if it was shown for a very brief time, even if it's 2 frames. We would expect you to account these slides, because after all, we are evaluating the efficiency of your solution, and if something was shown, it's better to be predicted. We are not modifying the original video files and providing them as is, as they were recorded here on Zoom. And depending on what was the presenter desktop size, the resolution of videos might vary from 1060 and to 4K. Next slide, please. The ground truth format, it's basically this is a format which is going to be put in the data set and can be used for training and evaluation. So we have several columns here. The column which is the second and the third column is it and on this so the second column and the third column, it defines the starting of a slide. I mean the beginning of a slide. We use 2 columns to define a start of a slide, and we also use 2 columns to define end of a slide, mainly because there is a possibility that there will be there might be some kind of animation which comes before the slide or after the slide, and when the animation happens, we can't really decide which frame is actually a starting one for a slide, and that's why we are providing you with this range of possible starting frames for a slide and of possible ending frames for a slide. And then the next 6 columns are related to the titles. We created many columns here out of sense that there could be several potential titles which are relevant for a slide, or sometimes there could be 2 equally important titles. So that's why if you see several titles specified on the same row, it means that you would probably have to predict one of them. But then there are additional columns which called bonus title 1 and bonus title 2. These columns specify special. I mean, these columns would have some value when there is a special case, such as a title is float for some reason, and we would provide here of something which we expect as a complete answer for a question of a title. Generally, you should go to our dataset and see how we define titles and bonus points titles, and this should give you an idea of what is expected. So perhaps next slide. So here we introduce the concept of a floating boundary. Basically, this is the same thing as I talked before. It's when the slide has animated effects such as fade in this example, we would specify the initial frame when this animation starts and the ending frame of this animation. And so basically we are doing this so that you can have a flexible training where you yourself choose what should be the initial frame of a slide. And you should also take into account that we would accept any frame within this range as an answer for to be predicted and evaluated. Next slide, please. Some titles feature, I would say, special characters which are not very compatible with the optical character recognition software. And one of the problems which any could encounter is that when you try to read the $, it would be recognized as an S, and the same goes for Greek letters and any kind of non-standard character. And what we're going to do to tackle this is, first we would provide you with an evaluation metric, which basically normalizes every title, both in ground truth and in prediction, by converting such a special cases of characters to a normal form, I would say. And this should kind of level the play field, and basically you should not worry about the fact that optical character recognition can provide wrong characters for you. And an additional thing which we would do as well is we would convert all the titles to the lowercase, and we would remove the redundant punctuation characters, so that there is no, so that really we minimize the possibility that you would not earn points because your optical character recognition software did not perform a good job for you. Next slide, please. We have sometimes, and I'm not really sure why, but in some presentations there could be a distortion to the desktop of a presenter, and this distortion can affect the title of a slide, and it becomes unreadable or maybe hardly readable. And we would account these cases in the ground truth by providing first a simple version of this title, which is easily readable by anyone, both human and machine. And then we would provide you a bonus point answer, which is a real title, which was put by a presenter on this slide. And if your solution manages to predict this title instead of a normal one, you would get double points for a correct title for this case. Yeah, perhaps next slide. Here, I would explain to you the overall evaluation workflow, so that it is clear how the accuracy is going to be calculated. The first thing which we would do is we would take your predicted slides, and we would do some kind of aggregation based on identical titles, meaning if your solution predicts two slides with identical title, we would join these two slides as one slide, and we would do the same for the ground truth. And then we would join, we would pair the predicted slides and the ground truth slides based on similarity in frame boundaries. To do this, we would use a metric called intersection of a union. It would calculate the similarity between the two spans, and basically for every ground truth slide which we have, we will find a predicted slide which has the biggest similarity in terms of frame numbers. So basically, and the next thing which we would do is we would apply a threshold to these pairings, and this threshold currently is 0.99. So you should really predict the exact frame boundaries of every slide. But one thing which is good is that we constructed our dataset in a way that we try and account for any potential cases which could affect the frame boundaries, such as animations and any kind of case which has many interpretations. We try and account it in ground truth, so that this way, when you do your prediction, if you manage to have an answer which is one of the options which we provided in the ground truth, you would get a point for prediction. So when we're checking the boundaries of a predicted slide and a ground truth slide, we expect that it would be almost the same boundaries. So the intersection of a union should be equal or more than 0.99. The next thing which we would do is we would go through all the pairs of predicted and ground truth slides, no matter if there was a good threshold or a bad threshold, and we would attempt to verify that the title was predicted correctly. To do this, we would normalize the title, as I explained before, and after we normalize the predicted titles, we would be comparing basically the strings of predicted titles with the strings of ground truth. Sorry, the strings of predicted titles and the strings of ground truth titles, and we would use a Levenstein distance, which should not exceed 1 character. So it means that you can, if your solution occasionally mispredicted 1 character in the title, we would accept it as a correct answer. And please consider the fact that there would be many options for the title on some slides, where there are difficulties in identifying what is the right title. And then the steps number 3 and number 6 is we would calculate the boundary and title accuracies separately, and basically the accuracy calculated is simple. It's we would divide how much times did you predict it, how many successful predictions your solution did versus how many successful predictions could be done in our test set. And the same goes for the title accuracy. And then we would apply a weighted average to the boundary and title accuracies with a little emphasis on titles, because we believe that predicting titles, it's a little bit more tedious tasks than predicting slide boundaries. Next slide, please. So I should give the floor to my colleague Bastiaan.
Yes, thank you, Kirill. Well, as Kirill gave an overview of exactly what the challenge will look like, what the nitty-gritty of the challenge will entail. We hope you're interested in participating, and we want to mention a few things. So first of all, we already have a training dataset that is live, and the submission form as well. So you can already get started. And so I'm going to flip right to the next slide. Here you see the URL, and if you're on a computer or looking at this on a computer and you have your smartphone at hand, you might also open it using the QR code, which directs you to the same URL. And there you can find the first batch of the training data and more training, which will definitely get you started and keep you busy for a number of hours. And then we already have in the works a new batch of training data that will be coming up later today, probably around 7 o'clock tonight, European time. And then more data also to follow tomorrow. So please have a look at the challenge, which you can find here at the URL or using the QR code. The first data is already there, and the more data with the same distributions to follow. And you can also contact us. So you see my email here at the bottom, and you see Kirill's email here at the bottom. Just send us an email, copy us both. If you have any substantive questions, you can also ask questions to the machine learning 5G team, specifically when it comes to the more organizational aspects of the challenge. And I think with that, we can then move to the Q&A. And so I would hand it over to Vishnu.
Thank you for the interesting talks. So I'd like to start the Q&A session. Again, if any participants have any questions, please type them in the video wall and we will take them right now. I'm going to hand over the floor to Vishnu, who is going to moderate the Q&A session.
Thank you so much, Miya. And thank you, Bastiaan and Kirill, for that excellent presentations. Well, I'm going to ask you a few basic questions first, purely from a participant perspective. Really, if I have to participate in this challenge, then I guess these would be the questions which one could think of. If you go to slide 11, Bastiaan, if you mentioned about if you look at slide 11, you see three main concepts here. If a participant looks at it, first one is that you see video. Second is that you see a frame, and then third is that you see a slide. So these are the main factors that you're playing with here, if you will, right? So could you explain the relationship between these three main concepts? What do you mean by a video? I mean, it's quite obvious, but and what do you mean by a frame? And what do you mean by a slide? According in the context of this particular problem statement.
Yeah, thank you, Vishnu. So I hope also that Kirill can join us and tell us the exact details, but maybe I can start with a quick high-level view of this. So the videos start with when the lecturer opens their presentation and ends when the lecturer ends their presentation. So the entire frame, barring elements in the middle, the entire video file has presentation. So it has a video feed of the presenter, and it has the screen share feed of the slides, which are then combined into a single video feed. And the video feed of the presenter is a small box in the corner, the way that you and I are now small boxes in the corner, presumably. And then the chapters are these segments which begin. So video files are coded in a certain way, and we expect that the participants that will be participating in this challenge have quite some understanding of how this video coding works, where each frame has a number, and these are just subsequent. So the first photo, if you will, of the video file is frame number 1, and then the second photo is frame number 2, etc. So every time point in the video file is covered by one of these subsequent frame numbers. And these are the perfect way to delineate the segments of the video which we're interested in. So these segments are what are called chapters on the various online platforms. We expect the participants to submit the beginning frame and the end frame. And as I mentioned earlier, we expect this set of segments to be collectively exhausting in the sense that it covers jointly the entire video file length. And then the titles, this is, as Kirill mentioned, something that is typically straightforward and has an AI element in the sense of an OCR. You might think about complexities here that can occur, such as the $sign, which is similar to the S. But then there are also more complex situations like partially covered titles by images, titles running off the screen, no titles, multiple titles, and when there is no slide being shown because the presenter, for instance, moves to a video demo. So with that, I hope I sort of gave an idea of how these different things, how we look at these different elements. And I don't know if Kirill has something to add to what I said, or maybe correct me.
Thank you, Bastiaan.
Yeah, Bastiaan, it's you said it correctly.
Okay, thank you.
Thank you, Bastiaan and Kirill. Let's take the next question. Are the videos mostly from YouTube webinars? And if so, are we kind of biased towards other videos? I mean, there are different types of videos out there in the world, right? So I guess the question is, if you look at the type of videos, are we kind of biased in the sense? I think you already mentioned about the slides aspect of the videos. I think Bastiaan already mentioned. Maybe that's something which you might want to touch. But can we say that they are similar to other presentations? That's a good question as well. And is there a bias? Yes, please.
Okay, let me try and answer that. I think there are several elements to this question, but firstly, let's say that we take YouTube as a whole and all the different videos that exist on there. Yes, there's a wide variety of things there that are vastly different and wouldn't be covered, so that it would have, you might call that different distributions than the data set that we're publishing here. You have people that live stream from their phones. The orientation of the video feed might be in portrait instead of landscape. There might be no screen sharing. There are many different things that can be different. And even if many of these things are similar, if you listen to a song of the Red Hot Chili Peppers, those are very well segmentable actually, because you have the chorus, you have the different sections of the song. But that's not something that a model designed to compete in this challenge would be good at. And I think that while there may be potential for models to do these different things, I do think that we see different categories of videos that exist. And for this challenge, we've chosen to first focus on a category of which we think the added value is great. So online lectures provide a lot of information, and we really can enrich the information of these lectures with the metadata that we want to be generating here. And that's where the focus for this challenge comes from. Then, to take it to the other element of the question, would it be similar to other online lectures? I think to a large extent, yes, there are differences. We do focus on a specific part of the whole presentation. So if you take an AI for Good video, we will begin with an introduction by our avatar that we just saw, Anna. We then have some talk without screen sharing taking place. And then there's the screen sharing, and then there might be some more talk without screen sharing place, such as right now. So we focus only on the segment of the video where there is the screen sharing taking place. And that is in many ways very similar to other online presentations. So for instance, we use a major communications platform to generate the AI for Good videos. And this is used by many of the other generators of content of lectures that you can find on all these video platforms. So it will be broadly similar. I hope that answers the question a bit. And if Kirill has something to add, and otherwise also for more clarifications, I do encourage, please let me know if you need more information. Also reach out via email. Over to you, Vishnu.
Thank you, Kirill. Would you like to add some thought?
I wanted to complete Bastiaan's question. I would say one interesting thing, which is about the data set which we are giving out to the public, is that when you go through it, you could really see that the presentations were made from people really from very vast backgrounds and I would say countries. And this data set, it's basically we are an international team, and people who come here, they come from every corner of the world, and this makes this gives us a unique I would say a unique perspective on how people do slides. And I would even say that if we trained on some more general data set and we would try to apply such a solution on our data set, we would probably not get a good predictions, because our presenters, they are much more creative than the average, I would say slide maker. And especially they come from science, they are standardization experts. These people think differently. When they create slides, they think differently. So that's why. But we also have a fair share of, let's say, easy cases, and so that's why I would assume that our data set it's kind of universal to be applied on lecture videos.
Maybe if I may add just one small thing to it, maybe it's already been said a little bit, but we are also aware that we're creating a new sort of problem statement here. This is something that doesn't really exist yet, hasn't really been researched in open communities as of yet, that we know of at least. And so we want to create a sort of limited heterogeneity in these distributions here, so that participants can start with this challenge and generate solutions that have a real world application. And then, of course, we are interested in developing this into a community that tackles more and more complex types of situations as we get further with this.
Thank you so much, Bastiaan and Kirill. There is a question from Rob. Actually, we discussed this in the early stages of the problem statement, but I will leave you to answer it. Would participants be rewarded for developing solutions that can identify the difference between key topic and the subtopics? I think, yeah, this is something. Yeah, please go ahead.
Thank you. Yeah, I'll get started, and then Kirill can jump in at any point if he wants. So thanks, Rob, for the question. This is a very good question, very valid, and I think something that's come up a number of times also in designing this problem statement. And I think, well, going back to the point that I was just making, firstly, we're kind of in creating a new community here as a new type of problem statement. So we want to have a sort of reasonable level of complexity in the problem statement. And secondly, also, I would maybe mention to keep in mind sort of what the objective with these models is. So we're probably not trying to create an entire mind map of the content of the lecture, but we want to be able to create these video chapters so that viewers of these lectures can ingest and get a good structure or overview of what's being presented. And for that, we only have one level of titles for the chapters and no sub-chapters. Yeah. So I hope that answers the question. And then it is, of course, a very interesting point that we might be thinking about that later on. But for now, we'll focus on the single level.
Understood. Yes, thank you so much. Slide 11. I think there is something interesting there again. apparent title. So I think Kirill already kind of talked through it, but let me ask this again. Apparent title. So I think this you already touched upon also, Bastiaan. You talked about OCR. I think you mentioned OCR. That means if I put 2 and 2 together as a participant, if I put these 2 and 2 together, so that means that there is an assumption that the title is apparent from the slide. So that's the first assumption, apparent. And the second assumption is that you can potentially pick up the title from the slide using, let's say, OCR, as you mentioned. Well, what is not apparent is that you may synthesize your own titles. That's not apparent. Can you explain what is apparent title and what are the ways one can derive this apparent title?
Well, as you said, I did touch upon it briefly, but I think we'll have to defer to Kirill's in-depth expertise momentarily. But yeah, so the example that we gave was the presentation in the AI for Good webinar by Ekshembeev of DeepMind on using mathematics or using AI for mathematical discoveries. And in that presentation, he shows that they had a publication in the Nature journal, and that slide doesn't have a textual title in the sense that there's text in the sort of PowerPoint file, but the biggest text is the image of the cover page of the Nature journal, that edition. And the largest text in that image is the title Nature, but the relevant part is the journal publication. So the article, the title of the article that's published. And so that's what we want people to pick up here. And there's a distinction there, and there's an element of intelligence that needs to be applied there. So yeah, we do, in a sense, this is an AI challenge, and many components or some of the components can perhaps be predicted quite procedurally, but there are some more complex elements to that. Yeah, maybe Kirill, I do think you can maybe give some more background.
Yeah, Bastiaan, I second everything that you say. I would add that we try to refer to the fundamental principle of a title. Is that a title? It's something that should summarize what you see with your eyes, and it means that when we are applying this definition of a title in the context of a slide, it means that whatever is shown, we want to know the title of it. If, as Bastiaan mentioned, if some journal is a screenshot of maybe of some gazette or of some journal has been placed on a slide, we would like to know the title of this article or journal, and not the name of the journal, but I would say the heading of the journal. And if some table or diagram is there, I mean, the only thing which is shown on a slide, it's a table or diagram, and it has a title, I mean, a caption underneath. We would want to know this title. And we also want this in a way that would let us create meaningful chapters on YouTube. So yeah, that's basically it.
Thank you so much. Quick question. Are these all English videos, or all the data set includes some other language?
Good. That's a very good question. And we do have a number of videos on AI for Good that are not primarily in English. Maybe the one that comes to mind for me is Iker Casillas, so the 2010 World Cup football goalie. I'm Dutch, and they played the Netherlands in the final of the 2010 World Cup. So I know very well who he is. And that lecture was in Spanish. But in the dataset that we are distributing, the training dataset, everything is in English, and we can also vouch for the fact that all the test data files are also in English. Not every single phrase, but that is the language that's used. I hope that answers the question.
Yeah. Thank you, Bastiaan. So maybe we can take a couple of more. Can the participants submit multiple options for the titles, or is that a fixed frame? Frame boundaries and slide and one title. Can you explain if there is ambiguity? Can I give multiple options?
Sorry, I didn't quite entirely catch if this was a question only about ambiguity in the text of the title or also in the frames, but I think I can maybe answer both. You can submit one option for the title that you want to predict, and for the frames, you can also submit only one, but there are cases where, for instance, there's a transition animation, so that there are several frames that are correct, that we label all of the frames in the animation as correct. And then to add a little bit to the first point on the title, in some cases, for instance, where the title is cut off by an image or because it runs off the slide, what is correct is any element that contains all the text that is visible, and bonus points will be awarded for those submissions that manage to predict the remaining segment of the title that isn't visible from the elements that are visible. So bonus points are awarded for that, but anything that has all the text that is visible is correct. I hope that answers the question.
Okay, so you expect one title for each slide. I think irrespective of the boundary ambiguity, but you expect one option for the title, right?
That's correct. Or where there is none, it can be none, but it cannot be more. Yeah.
Understood. Thank you. I think in slide 16, Kirill mentioned about the resolutions. So can I, if I have, say, GPU problems, or I don't have access to GPUs, let's say, can I train it only on low resolution videos and try to win it, or is that something which you would not think as possible?
I'll definitely ask Kirill to also speak to it, but my 2 cents would be that yes. So if you use tools, for instance, if you can to compress the video into a lower resolution or a lower number of frames, I think these are both options, then you can definitely get to a much lower GPU or TPU or CPU requirement threshold. And the transitions will still be visible at any, let's say that I believe that the lowest resolution, for instance, from YouTube is something like 160 by 250 or something along those lines. So much lower, various order, at least an order of magnitude lower than, various times an order of magnitude lower than the higher resolution. And that's still sufficient to detect the transitions and normally, typically at least, also to see the title text. Yeah. But you might want to experiment with it. It might not be that the lowest resolution will work perfectly, but lower resolutions than the ones provided should probably work. And then I want to also point out that you probably do not need all the frames. And then Kirill might want to join.
Yeah, I would say that if we train a solution on a much lower resolution videos, we can come up with an effective solution. It's just my fear is that if you don't use the maximum resolution available, there would be like maybe a very tiny % of cases which you could miss because the resolution was like too tiny. Sorry, the resolution was too small to catch the transition. But this would be really tiny % of all the cases. I imagine that. So if participants want to use the highest resolution available and save on GPU power, I'd recommend to do some kind of pre-processing on these videos And by pre-processing, I would advise everyone to take benefit of the fact that slides are generally a static thing, and to catch a slide transition, you don't have maybe you don't have to check every frame, but instead you just have to see if the visual, I mean, if the frame has changed visually from the previous one. I mean, you can compare the pixels of the next frame and of the previous frame, and because we have a slide content in our videos, in most of the times there will be like I would say an exact match of pixels. And this way you can identify segments when nothing changes in the video, and you don't really have to process these segments because all these segments can be reduced to a single frame because all the frames are exactly the same. So as Bastiaan mentioned, I would say there are two ways to save the computing power. One is to reduce the resolution, and the second one is to try and apply some pre-processing to the videos videos, and one of the options should help.
Thank you. Yes,
maybe if I can add a final, just a very short comment to that, Vishnu. Sorry to interrupt. That this is something that we actually discussed quite quite extensively during the planning of this challenge. Is whether we should be supplying lower resolution videos or lower frame rate videos. And in the end, the decision was made to leave this strategic approach with your counsel, actually, Vishnu, to the participants themselves. But it is definitely something that we expect that, at least to an extent, you might be able to make your computation more efficient without hurting your chances. Yeah.
Interesting. Sorry. Yeah. Thank you so much, Bastiaan and Kirill. I want to ask maybe one last question. Maybe before that, the GPUs question. So ITU does provide GPUs free of cost, and we will put the link in the neural network. Please watch the neural network. We will put the link to the request where if you are registered for these problem statements, then we do provide access to ITU GPU cluster, and you can request. So we watch the neural network. Can I maybe ask one last question about slide 21? So Kirill showed this flow of evaluation. Thank you so much for that. So in slide 21, yes, thank you, Bastiaan. The question is, are these strictly sequential? So is the flow strictly sequential? So slide points 2 and 3, for example, and 4 and 5, for example, are they strictly sequentially done, or are they gated? Or are they done in parallel? Are they done evaluated in parallel, please?
So I'm going to defer this question to Kirill because this is his remit.
Yes, Vishnu, you're right. It's a sequential thing. First, we calculate the boundary accuracy, and then we calculate the title accuracy. But we do not reject predicted titles if we rejected the boundary. So if we have a predicted slide in a submission and the boundary for this slide was rejected because the threshold was not high enough, we would still try and evaluate the title in the steps number 4, 5, and 6.
Okay. Thank you so much. I think you have been very helpful and great explanations. Thank you for patiently answering these questions and bringing this large data set of videos, very interesting videos. Thank you. Back to you, Miya.
Thank you very much. Thank you everyone for sparing your valuable time today to join today's session. I would especially like to thank Bastiaan and Kirill for explaining today's problem statement, as well as Vishnu for moderating the Q&A session. Please note that the challenge is currently open for registration and participation. The link for registration is posted in the video wall. You can start working on your solutions and submit the results in the portal. We have more sessions planned in the near future, so please check the AI for Good program page for details. You can also interact with us and other participants on the Challenge Slack channel. We are looking forward to your participation in the 2022 edition of the ITU AI/ML in 5G Challenge. Thank you for joining today's session and have a good day.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. After the networking session, we invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for Good.